Welcome back, everyone, to this new episode where once again we'll get to analyze how computer vision systems work and how they're built. In the last episode, we started to understand how cameras work and how the sensors inside them function. We saw that a sensor is the component that can convert light information into digital information, thus creating the actual image. In this episode, we'll focus again on the camera itself. We'll look at how certain parameters work that control the actual formation of the image. In the previous video, we saw that the camera is mainly made up of two components. A sensor, then, is the component that can convert light information, photons, into electrical information, electrons, and the control. The electronics is the part that transforms those electrons into digital information, resulting in the final image. In this episode, we'll focus again on the control electronics, looking at how certain parameters come into play in the transformation from electrons to the final image. So, we'll look at the concept of exposure time and that of the shutter. And we'll wrap up by talking about the different interfaces that allow the digital data to be transferred to the final processing system. Let's start by talking about one of the main parameters, if not the main one, that controls image capture with cameras, the exposure time. Exposure time is the time interval during which light hits the sensor. Inside every camera, in fact, there is a shutter, in this case, an electronic one, not a mechanical one, that, by opening and closing, allows light to pass through and hit the sensor. By adjusting the speed of the shutter, we can allow more or less light to pass through and reach the sensor. So you can see how adjusting the exposure time changes the amount of light that hits the sensor. This will result in final images that are either brighter or darker, depending on how much light actually hits the pixels of the sensor. Looking at the images, you can see how short exposure times, and therefore high shutter speeds, result in very dark images, since only a small amount of light hits the sensor. But as the exposure time increases and the shutter speed decreases, the image will become brighter and brighter because more light will reach the pixels. However, be careful, because the exposure time doesn't just affect the brightness of the image, but also its sharpness. A longer exposure time, in fact, means the shutter stays open for a longer period. And if, during the time the shutter is open, the object being captured in the scene moves, then the light reflected from it will hit different pixels, producing a motion blur effect in the image. In these images, we can see these effects more clearly. In the images at the top, the exposure time is very long, and as a result, I see motion blur in the images, even though it isn't actually there. For example, I can see the movement of the stars. In the images at the bottom, on the other hand, the exposure time is very short, so I'm able to capture a snapshot of the movement. In this case, the objects are moving very quickly, but the image isn't blurry at all. In fact, I can capture the falling water very well, or the finish of the 100 meters at the Olympics. Longer exposure times allow for brighter images, but if objects are moving, the images are less sharp. On the other hand, shorter exposure times let you capture moving objects more clearly, but the images will definitely be darker. Now that we've seen how exposure time works, let's move on to analyze the second parameter of the camera, the shutter. In every camera, in fact, there is a shutter, which, as we've seen, is electronic, not mechanical. This allows light to either pass through or be blocked, so that it either hits the sensor or not. There are two types of shutters, those called global and those called rolling. The difference between these two types lies in the way they let light through so that it hits the sensor. In cameras with a global shutter, all the pixels are activated at the same time. So, instantly, the entire sensor lets light through, and all the pixels capture the light at the exact same moment. In cameras with a rolling shutter, on the other hand, the light hits the pixels at different moments. Specifically, this happens row by row. Usually, the pixels in the first row are activated first, then those in the second, then the third, and so on, all the way to the last row. So, in terms of timing, the light that hits the first row of pixels arrives at different moments compared to the light that hits the last row of pixels. With a global shutter, all the pixels are activated at the same time. With a rolling shutter, on the other hand, the pixels are activated row by row. The control electronics for rolling shutter are definitely simpler, and that's why rolling shutter cameras are much more affordable. Just like with the concept of exposure time, the different ways pixels are activated also lead to different effects on the image. In this case, it's very important to understand how fast the object I'm filming is moving. In fact, rolling shutter cameras are only suitable for capturing stationary objects or those moving very slowly. This is because fast-moving objects would cause distortions in the image that aren't present in the real scene. For example, if I want to film a spinning fan using rolling mode, the resulting image will be completely distorted, even though the fan blades themselves aren't actually distorted. This effect, on the other hand, is completely absent in global shutter mode. Finally, let's wrap up by talking about camera communication interfaces. Over time, each manufacturer has developed different types of interfaces, and therefore, different communication protocols and standards. Each of these standards has its own specific features. These four are the most common interfaces. Each one has different characteristics in terms of transfer speed, maximum cable length, and the maximum number of devices that can be connected. So, when designing any vision system, it's important to pay attention to this parameter as well, since it could be crucial for the operation of the entire system. Let's now summarize the concepts we've covered in this episode. Exposure time indicates how long the pixels are exposed to light. This parameter is important for getting images that are either brighter or dimmer and more or less blurry. The type of shutter, on the other hand, indicates how the pixels are exposed to light. In this case, it's important when dealing with objects that need to be measured and are moving quickly to avoid getting blurry images. Finally, the connection interface represents the way digital information is transferred to the processing system, which is important for understanding the transfer performance and speed of the final measurement system. In conclusion, today we looked at the most important parameters that govern image acquisition. At this point, in the next episode, we can go into more detail about the image and understand how it is formed, so that we can see how it is possible to work on it.